All right, for this video, we are going to go through the next set of most missed questions that we had on the test, on the post assessment, I should say. The first thing we did was 10 through 1 through 10. And in this session, we are going to go through 11 through 20. All right. Now, this isn't going to be Mr. Williams gives all the answers to all of these things because that will take much too long. Instead, what I will do is go through each one of these and give a general overview for how to do them or how I can think about them, how I usually think about them, and how you can think about them if you're not quite sure how to solve the problem. Some test taking strategies. All right. So this is just the title page. The first one is going to be this one here. It says, what is the range of the graph? When we're dealing with and talking about range, our range is going to be our y values. What color am I going to use? Let's go blue. Yep, our range, those are y values. This is something we did way back in that first marking period. So you got to think back to that stuff, unit 1. Our range, I believe that was unit 2 actually. That was unit 2. Our range are y values. Domain is x values, but in this case, it's just asking about the range. And so that immediately, since we know range is y, that immediately eliminates A and C. And finally, when we're looking at the range, for range, we're going to look up and down. If you see this y right here, how the arrows on this axis go up and down, that's what we're going to look to find what the range of this graph is. If we go from top to bottom, we see that every number up is covered because this graph keeps going up in both directions. But once we get to this point here, this line here at -4, we don't have any other values, okay? So the answer to this one, the range for this is gonna be y such that y is greater than or equal to -4, okay? So you see this -4 right here? Anything below that, we don't have any range. There's nothing on the graph below this, but everything above it, we're good to go. That's why it's going to be B. All right. Now, if you don't understand some part of that, remember you can come back to the Zoom chat and ask or review those unit 2 notes. I believe that's way back there, but you can do that. All right, this says, given the function f of x is equal to 5 minus 3 halves x and the domain -2, 0, 4, find the values of f of x for each element in the domain. All right, so the way you're going to do this one is going to be to substitute, okay? There are 2 different ways you can go about this one, but in essence, they're both still substituting. The first one is to solve it by hand. If you were to plug this in, solve it by hand, you have 5 minus 3 halves x. Take this first one, this -2, plug that into this x one. Whatever you get for that would be your value. If you were to do that, you'd end up with 5 minus 3 or 5 plus 3. That would give you an 8. And then you do the 0 the same way, then you do the 4. Alternatively, you can plug this equation into Desmos and substitute those numbers by typing them in into Desmos, so you're not actually doing any math. And this is going to be one of the ones where I'm just going to explain the process and I actually give you the answer. So if you want to check it, go try it out. And if you have questions, once again, come back to that Zoom chat. All right, next one, we have, what is the 0 of the function f of x equals 2x plus 6? All right, and this one, I'm going to bring up Desmos just because it's really useful for these types of equations when we want to see the graph. F of x equals 2x plus 6. I'm going to type that right into my Desmos. F of x equals 2x plus 6. And then when it's asking us for zeros, that's the same thing as solutions and intercepts when we're dealing with our x values, okay? So the 0 is going to be the x-intercept, also the solution. And this thing is crossing, my x-intercept is where it crosses the x-axis. It's going to be right here at -3. And so that is going to be the 0 of this function a, all right? This is what I wanted you all to see what it look like in Desmos in the graph so you all get familiar with that. But just a reminder, zeros, intercepts, solutions, zeros, x-intercepts, and solutions, those are all interchangeable. Those all mean the same thing. However, y-intercepts, not quite the same thing with that. It's only for x-intercepts. So don't let that part confuse you. Once again, if you have questions, you can come back to the Zoom chat and let me know, and I will work with you. Next question says, write the equation that is represented by the data in the table. Excuse me. To do this one, um, you're going to kind of compare and contrast. The first thing I would do is I would look to see if I had a y-intercept. If you're going to have a y-intercept, uh, you know what? Scratch that. No, don't do it that way. There's an easier way to do it. The way to check to see if the data in this table matches with any of these is just going to be to plug them into the graph or plug them into the equation, the points in this equation, into one of these equations and solve. So let's, if we wanted to try this first equation, equation A, we take that 4, plug it into the y, equals -4/5. My x is -5 plus 2, and then solve for it. If you get the same answer on both sides, then you know that's going to be the equation. So let's go ahead and solve for this. -4/5 times -5, that's going to leave me with +4 plus 2. +4 plus 2 is going to be 6. That's not going to be it. We know it's not going to be A. All right, so when you're doing this, you go through and you check each of these, plug it into it, substitute, and then that will give you the correct answer. You can also do the same thing in Desmos, substituting that way. That might make it a little bit quicker and it may make you less prone to make mistakes. So I do recommend doing it that way as well. But that's how you're going to tackle this one. And I am going a little bit fast with these. If you need to pause it or rewind it or something to rewatch it, definitely do that. And if you have questions, come back to the Zoom. All right, next slide says, which point is a solution to the inequality below? If you think back to, I believe this was unit 2 or 3, I don't quite remember, when we were talking about the solutions to an inequality, uh, it's going to be something that keeps that inequality true. So we want to find the solution to this inequality. A point that is a solution, that is a possible solution, will keep the inequality true. And to test that, very similar to how we did the last one and the one before that, we're going to take these points and plug them in. All right, so we're going to have 3x minus 2y less than 10. If you wanted to take a point, let's say this first point here, A, and test that one, you do 3, 3, and then your x value here is 0, minus 2 times -5 is less than 10. And then you solve these. 3 times 0 is 0. And then 2 times -5 is going to be -10. So that'll be a positive 10. Is 10 greater than 10? No, 10 isn't greater than 10. 10 is equal to 10. All right. So that would not be a possible solution to this equation. And then you go and do that for the other 3 points in this question. All right. So I do believe that's well within you guys' capability. If you want to make sure you're not making mistakes on these, you can type this into Desmos like the previous ones, and that will make it a little bit easier. All right. Next one says, an empty book crate weighs 30 pounds. What is the greatest number of books weighing 1.5 pounds each that can be packed in the crate if the filled crate may weigh no more than 60 pounds? Now, the first time I read this one, I was like, ooh, that's a little confusing. So I definitely recommend reading it again. An empty book crate weighs 30 pounds. I was like, why did they give us that? That doesn't seem important, but it is important. An empty book crate weighs 30 pounds. What is the greatest number of books weighing 1.5 pounds each that could be packed in the crate if the filled crate may weigh no more than 60 pounds? So the weight of the crate and all the books in it has to weigh less than 60 pounds. And I've kind of already given a little bit of the process away. This is when I'll probably go through a good portion of it. So since it can weigh no more than 60 pounds, that goes back to our inequalities, those keywords there. Weighing no more means it has to be less than. So we know something is going to be less than 60. And then we have to figure out what the rest of this is going to be. We know it starts off weighing 30 pounds. We can't change that at all. 30 pounds. But it will also weigh 1.5 pounds for every book I put in it. Let's do B for book. For every book I put in it. Now that I've set this inequality up, I can go ahead and solve it. So I'm going to subtract 30 from both sides. Minus 30, minus 30, 30 minus 30 is 0 over here. I have 1.5b is less than 30. All right. And then you're going to divide both sides by 1.5. All right. I'll save that that portion of the arithmetic for you to come up with the rest of this answer. But that's how you're going to do this. The tricky part here isn't the math, it's the setup. So you want to make sure you're careful with these and you keep in mind those keywords that we use when dealing with inequalities, okay? And once again, this is one, if you need help, come back to Zoom chat and let me know and I'll help you. The next one we have says, which of the following systems is represented by the graph? This is one I'm kind of just going to walk you through. I'm not going to go through the entire process. I'll show you the best approach and then let you do it for the rest of them to find the answer. All right, so which of the following systems is represented by the graph? What we're going to do is going to plug and play, kind of match what we get when we plug it into Desmos with what is given to us. Here we see that our first system, y is less than 2x plus 1. Let's go ahead and plug that in. Y is less than 2x plus 1. Didn't even type. Y is less than 2x plus 1. That's one of our equations. And then our second equation for this system is x minus 3y is less than or equal to negative 2. X minus 3y is less than, and to get that less than or equal to, you just type the equal to sign, or you could bring up the keyboard that's down here, and that'll give you that option as well. I think it was a negative 2. Let me go check though. Yep, it was a negative 2. And here we see this one actually looks really close. So what we're looking for is just this overlapping shaded region. We see that it overlaps right here at this point, negative 0.2, negative 6. And then we want to make sure we pay close attention to how these lines are. The line on top that starts on top goes through and it's a solid line. The line that starts on the bottom goes through and it's a dashed line. So you want to make sure you're paying attention to these. And it looks like that actually was the answer for this one. All right. But check to make sure that it is the actual correct answer. Sometimes they're a little tricky and I'm not being super duper careful with these. You want to check to make sure your intercepts match up and all that other jazz also matches up. All right. So make sure you're checking these carefully because it is really easy to miss it just because you weren't being careful. You were trying to be quick and not careful. So check each one. And then if it looks like it's A after checking the rest of them, then you're probably good. If you can easily rule out the 3 options, then you know you're good. And that's a really big and important test taking strategy. If you can cross out some options, that improves your chance of getting the correct answer. And if you're confused on this one for whatever reason, come back to the Zoom chat. I'll help you out. All right, which relation is a function? This is going way, way back to unit 2. Remember, a relation is just a list of ordered pairs, and a function is a list of ordered pairs in which the x value does not repeat. So we cannot have any repeating x values, okay, for it to be a function. If it's a function, none of the x values can repeat. Can the y values repeat if it's a function? They absolutely can, but the x values can't repeat. When we're looking at a set of points, we're going to make sure the x value, we're going to check to see if the x values repeat. If any of them repeat, then we know it's not a function. We have a negative 3, negative 5. Oh, we got a negative 3 here and a negative 3 here. That's not a function. We have a 4 here and a 4 here. That's not a function. When we're looking at a graph, points on a graph, we're going to use what's called the vertical line test. Can I pull up a line on this thing? That's a text box. That's a shape. Nah, I probably can, but I'm not going to fuss with it. When you're using the vertical line test, take your pencil or pen or something, hold it up to your screen and drag it across. If at any point your pencil or pen touches more than one spot on that graph, then it's not a function. Doing that with C, we see that it's completely touching this whole line. All right, that's pretty obvious for that one. And so that only leaves D as our option. We just eliminated every answer. We didn't have to think about it too much. And if that's confusing, once again, come back to the Zoom chat and I will help go over that stuff with you. Did I skip one? I did skip one. What values of W make this inequality true? So this says 3 times the quantity 2W minus 3 is greater than 6W plus 7. This is one where you're going to have to go through and solve this inequality. All right. Once you solve this inequality, you will get your answer. So let's go ahead and do that. 3 times 2W. I'm going to write my work down here underneath it. We get 6W minus 9. And it's really easy to make simple arithmetic errors. and just mess up your multiplication or addition or subtraction or division. So be careful with that, all right? Is greater than 6w plus 7. Okay. Now, when my next step, I see that I have a 6w and a 6w, so I'm going to go ahead and do what I can with these w's. Move that 6w over, minus 6w. That crosses out and that crosses out. I've gotten rid of my variable, and what I'm left with is this negative 9 is greater than 7. Does that statement look right to you? Is negative 9 greater than 7? Nah, not even a little bit. Not even a little bit. And since we see it's not even close to being slightly correct or making any sense in this math statement, we know it's going to be no solution. Okay. That one, you just might have to reach way back and do some solving. But I think you guys get that. All right, and this last one says, what is the domain of the function? The domain is going to be all the x values. So this is kind of pairs up really well with the very first question was range. The very last question is domain. So when we want to find the domain of a function, first we should plot all of the points. Okay, just list all of the ordered pairs. I'm not going to go through that with you all because I do believe you guys can do that one. Once you go through the listing all the ordered pairs, you're really just going to write out your x values for your domain, and you don't want to repeat any. If there are any that repeat, you're just going to write it once. Actually, no, yeah, you're just going to write it once, and then you'll have your domain. Okay, that is the 11 through 20 most missed questions that we have on that post assessment. When you're done with this, get going on any missing work that you have or any IXLs or test corrections that you still have to do. Okay. And if you have any questions, once again, come back to the Zoom chat and I will help you out. Okay.